Okay? We need to find values of x. How do I know that when I find values of x? It's because of that interval. Okay? So, the first part, I'll do number 1 first. So, we'll cos x equal to sine 32 degrees. Okay? Now, this question here, you can't convert cos and sine to tan because on the left we have got x, which is an unknown angle. On the right we have got 32 degrees. So what you do is, you either have to convert the cos to sine or the sine to cos using co-ratios. Okay? Remember we did co-ratios right at the beginning of grade 11 trick. Okay? Just to remind you where we started. That's almost like 3 weeks break, I think. So sine theta is equal to cos 90 degrees minus theta. Okay, and cosine of theta is equal to sine 90 degrees minus theta. Okay, so we did that right at the beginning. So these co-ratios, you need them under trig equations. Okay? You need the co-ratios. Some questions you need the fundamental identities. Okay? Some questions you need your knowledge of quadratic equations, factorization, and so on. Okay, so you must be familiar with the different types. When you see a question, you know where to start. Okay, so here we have to use co-ratios. So it's your choice now. If you decide to use co-ratios, it's your choice whether you want to convert the cos to sine or the sine to cos. You still get the same answers. Yeah. So this, okay, for me, I'm going to convert the sine to cos. Okay? If I do that, this becomes cos x equal to, make sure you pay attention carefully. We subtract this angle from 90, then we introduce cos. So it's going to be the first one. 90 minus theta, this gives you 50. 50 what? 58 degrees. Okay? 90 minus 32 gives you 58 degrees. Okay? Now, let me emphasize this. Once you get here, you need to be aware that this is actually a ratio. That cos 58 degrees is a ratio. Okay? It's a ratio. But, so you don't need to use the calculator and find what cos 58 degrees is. If you decide to do that, it's fine, you'll still get the same answer at the end. But there's a technique which I'm introducing now for the first time. If cos x is equal to cos 58, it therefore means that x is going to be equal to 58 degrees. Okay? Yes. But the 58 is in the first quadrant. It has got a corresponding angle in the fourth quadrant. Okay? Yes. Remember, cos is positive in the first quadrant and the fourth quadrant. Okay? So we can simplify this by as x. You can write it as x is equal to plus or minus. Now our reference angle is 58. Okay? This angle of 58 becomes our reference angle, so it becomes 58 degrees plus. The reason why I'm putting plus or minus here is because cos is positive in the first quadrant and the fourth quadrant. And also remember that cos of minus theta is equal to the cosine of theta. Okay? So cos 58 and cos minus 58, they give you the same ratio. That's why we have got this plus or minus. Our reference angle is now 58. Okay? Then we put our k times 360 degrees, where k is an element of z. Please, I want you to know that this is not the only way of doing it. If you decide to convert that cos 58 to a ratio, then you end up having to use your calculator to find shift cos of that ratio to still give you 58. Do you understand what I'm trying to say? If you convert the cos 58 to a ratio, which will be a decimal, and then you try to find the angle by saying shift cos, you come back to 58 degrees. Okay? So there's no need, if you have got cos on the left, cos on the right, there's no need to convert this cos 58 to a ratio using a calculator. You can just know that, okay, since there's cos x here, there's cos 58, therefore means that x is equal to 58 degrees, but the 58 degrees is a corresponding angle in the fourth quadrant, which can be negative, and that's minus 58 degrees. Then you bring in the what? The general solution, because there are many solutions that can give you the same ratio as cos 58 or sine 32. Okay? So from here, we're almost done. We've got our two general solutions there. Then the next thing is to find what? The values of x now. Okay? This is the general solution. It's not the answer, but it is the way to the answer. Okay? So I found my two general solutions. Now to find x, then I'll say x is equal to. Now I'm going to substitute k now. Let's start with k equal to 0. If I put k equal to 0, I don't want the minus 58 here. I want the positive 58. Well, the positive 58 is between 0 and 360. So my first answer is going to be 58 degrees. Okay? Now, if you know your co-ratios very well, if you put 58 here, cos 58 is the same as sine 32. Okay? Then the other value of x, I subject 0, so I now need to substitute k equal to 1. If I put k equal to 1 here, I'll get 1 times 360. But here there's a plus or minus. I don't want the plus 58 because plus 58 plus 360 gives me a value which is above 360. I don't want that. So I'll say minus 58 plus 360. That will give me 302 degrees, which is an angle in the fourth quadrant. And this angle is equivalent to minus 58. It's only that minus 58 is negative, 302 is positive, but both of them are equal. Minus 58 is equivalent to 302 degrees. Okay? If I put k equal to minus 1, I'll get values that are outside this interval, which means we only have two solutions. Okay? Those are the two solutions. Are you following? Okay. Now I'm going to convert the cos to sine using co-ratios. So my next step is to write sine x minus 40 degrees is equal to sine 40 degrees. Okay? I hope you're all aware where I'm getting the 40 degrees from. I'm subtracting the 50 degrees from 90, then I'll get 40. And it now becomes sine 40. Now what this means is, this x minus 40 is equivalent to that 40 degrees. Then you bring in the plus k to the 60. So our reference angle is now 40. Okay? So the next step is to eliminate the sign on both sides, and then we end up having x minus 40. That's equal to 40 degrees. Now, this 40 degrees is your reference angle. And it's catering for the first quadrant. We also need to cater for the second quadrant. So I will do that later on. So that's 40 plus k times 360 degrees, where k is an element of z. So, okay, before I carry on, do you understand why you got this 40? Alright, let me take you to the basics. Let me take you to the basics of that. Alright, make sure you pay attention. Okay, yeah, that's why I'm saying wait, let me clear that air. Alright, let's start here. Okay, make sure you pay attention. Okay, let's forget about this step. This one here. Let me remove it. Okay, allow me to remove it. Let me clear that. Okay. I want to show you that it comes to that. Okay, from the basics. Okay, let's start from here. I hope you are all aware that by now, if you want to move from here to bring in shift sign, you eliminate the sign on the left, then you take it to the what? The right. If you do that, you get x minus 40 degrees is equal to shift sign of this sine 40. Now, the sine 40 is a ratio. The sine 40 is a ratio. So we have to write it as sine minus 40 degrees. Sorry. It's supposed to be sine 40, not shift sine 40. Like that. Please be aware that this sine 40 is a ratio. If you bring in your calculator, right? If you bring in sine 40 gives you this. 0.642. So when you say shift of sine 40, you are saying shift sine of this decimal. And that should give you what? An angle. That angle is going to be 40 degrees. Okay? Check this out. Okay, so it should be 40 degrees. So when you calculate that, and then I press shift sine, look here. Instead of converting the sine 40 to a decimal, if I press shift sine, then I'll put sine 40 inside brackets there. Okay? Okay? The good thing I'm teaching my grade 10 to be aware of that, because it helps them later to understand what we're doing. And then if you press equals, see what angle you get. You're getting what? 40 degrees. You see that in kids? Yeah. So what that means is your next step will be x minus 40 degrees equal to your reference angle is going to be 40 degrees. That's why I can move straight away from this step here. Look, I can move from here to that. Then I'll bring in my general solution. So this step, this one here, I've shown you because it helps make you understand where this final step comes from. Okay? When you've got K is an element of Z. Be aware that this is your reference angle. This is your reference angle. That's your reference angle. Which has got a corresponding angle in the second part. Okay, we are going to find that one too. Both sine has got two general solutions. So from here, we take the minus 40 to the right, then we get x equal to 40 plus 40, that will give us 80 degrees plus k times 360, where k is an element of integers. Okay, so we have our first general solution here. Then we need to determine the second one. Now remember, to get the second one, we have to subtract the reference angle from 180 degrees. Because this reference angle is in the first quadrant. And sine is positive in the first quadrant and the second quadrant. So the second general solution is going to be, okay, we start from here. Okay, we start here. We just have to subtract this angle from 180. So you end up having x minus 40 degrees is equal to 180 degrees minus the reference angle. Then we add k times 360 degrees, where k is an integer. You simplify that, you get x minus 40 degrees is equal to 140 plus k times 360, where k is an integer. Then your x is going to be 180 plus k times 360, where k is an integer. You take the minus 40 to the right, you get 80. You see this minus 40?
Yeah, so this one should be x only.
Huh?
Ah.
Okay. Remember, sine is with how many Jejunova solutions? So this is the first one. Okay? This angle is in which quadrant? The reference angle is in which quadrant? First, right? But sine has got two angles that are positive, that give us the same ratio, which is positive. One is in the first quadrant, the other one is in the second quadrant. So we can replace this 40 by another angle in the second quadrant. We don't touch the left-hand side. The left-hand side remains the same. All we have to do is subtract this 40 from 180. The left-hand side remains x minus 40. It will only change after you've incorporated the second angle in the second quadrant. So that second angle is 140. This 140 is also a reference angle. Because we can use it to find this. Okay? So our general solution is this. So we have got our two general solutions. I'm not done because if you look at the question, I need to find values of x between minus 360 and 360. Okay, remember I told you a few days ago that the matrix last week they wrote their maths paper 2. There was a question that was almost like this. They were finding the general solution and stopping here. A question which had 6 marks, so most of them were getting 3 or below. Okay? They were stopping there. Okay? So from here, we now need to find the actual values of x between minus 360 and 360. To get those values, we substitute. So we say, therefore, x is equal to, let's start with this one. Let's put k equal to 0. If I put k equal to 0, I'll get 0 plus 80, which means 80 degrees is the solution. If I put k equal to 1 here, I'll get 360 plus 80, which gives me 440. I don't want 440. If I put k equal to minus 1, I'll get 80 minus 360, which gives me minus 280. Minus 280 is in the interval, so I'll put minus 280 degrees. It's a solution. Right. If I substitute k equal to 2, k equal to minus 2, I'll get values that are outside the required interval. So I've got two solutions for the first general solution. Then I move on to the second one. If I put k equal to 0, I'll be left with 180. So 180 is the solution. Okay? If I put k equal to 1, I'll get 540. I don't need 540. If I put k equal to minus 1, I'll get minus 180 because 180 minus 360 gives me minus 180. If I move on to k equal to 2, I'll get values that are beyond 360. K equal to minus 1, values that are below minus 360. So it means overall I'm supposed to have 4 solutions that can satisfy that trig equation based on the required interval. So you have 4 solutions. Okay? This is how you will do it. Make sure you took note of how I explained this part, because it is very confusing to lots of learners. I took you back to the basics. And your grade 10 teacher was supposed to have enlightened you on this. Okay? If you didn't know, now you should know. This part was supposed to have been taught in grade 10. Okay? Any question? You're sure you don't have a question? Right, if you don't have any question, then allow me to move on to another example. The next example, it will be number 4. Okay, number 4. Number 4. Okay, so let me move on to the next page, number 4. Number 4 is tan x equal to tan 2x minus 25. Tan x equal to tan 2x minus 25. This one is not very long because the question wants us to determine the general solution. We don't need the actual values of x. We just define to determine the general solution. So it's a very straightforward question and it's very easy to do. So from here, since we have got x here, we have got 2x minus 25 degrees. By now we should know that this tan 2x minus 25, okay, it's a ratio. But because we don't know x, it means that if tan x is not tan 2x minus 25, means this x is going to be equivalent to 2x minus 25. Because on both sides we have got tan. So their angles are equated. Okay? Angles are equated. So your next step will be to drop the tan. You also drop the tan there. You have 2x minus 25 degrees. Then you bring in the k times 180 for the general solution, and that will be k is an element of z. So this will behave like it's your reference angle. Okay? Now fortunately, we only have one general solution for tan. So all we have to do here, take the 2x to the left, right? If you do that, you get minus x equal to minus 25 degrees plus k times 180 degrees, where k is an element of z. Then we divide both sides by minus 1. But we divide what? The minus x by minus 1, the minus 25 by minus 1. Let me indicate that. We divide this one here by minus 1. Divide the minus 25 by minus 1. Divide the plus k180 by minus 1. Okay? If you do that, your final answer is going to be x is equal to positive 25 degrees plus minus. Okay, it's very possible that you can have a minus here, depending on the question. So don't be surprised. For this question, involving a plus, the plus changed to a minus because of the nature of the question. So this becomes k times 180, but k is still an integer. Okay? So this will be your final answer. That's your general solution.
So, how come the 180 here is not here?
What?
180.
What?
How come like k times 180? How come you want to remove this side of the 180?
How come you go?
You see right here, from here, after you task by this y. If you divide the area, like how come this is coming in?
Oh, you see, it's one term. This k times 180, you can write as 180 this k, but because of the degree sign, we write the k first, then we put a dot, then we put 180 degrees. It's 110. It's k times 180 degrees. Okay? This is 110. That's very important. Okay? And then we are done. Okay? Any questions?